there, my name is Melissa Ubaldo and I'm a solutions engineer at One Spatial Inc. We are a US company that is a fully owned subsidiary of One Spatial Group in the UK. Our focus at One Spatial is on data management solutions to improve data quality for large complex systems. We use validation, integration, automation, and a rules-based approach to build strong data infrastructures leading to better outcomes and making our data smarter. So this is the second installment of our three-part webinar series featuring how we at One Spatial address data management solutions for clients in our facility management vertical. For those of you who have yet to view the first part of this webinar series, Kevin Sigwart, who is our Director of Solutions, demonstrated work related to what we're currently doing for organizations like Google Real Estate Worldwide Services. We partner with those types of organizations on their CAD data supply chains in relation to their asset management systems. He demonstrated how well we can help these organizations with implementing automated workflows by leveraging One Integrate and One Data Gateway technology stack to auto-validate and auto-clean the data and ensure that it is actually fit for purpose before being integrated into an asset management system. So this second webinar will be building on that. What we'll be doing is working with GIS facility data that has been derived from CAD drawings. And since asset management systems maintain more types of facility data outside of what can be stored in these CAD drawings descriptive data, we will promote the use of a centrally managed database across the entire enterprise by running rules that will actually synchronize these multiple sources of spatial and non-spatial data. But before we can talk about synchronization between GIS facility data and an asset management system, how about we assess the quality of our GIS facility data first? So as was mentioned in the previous webinar, 88% of all data integration projects fail, and one of the main causes of that is poor data quality. So it absolutely makes sense. When you're using poor data, it will pollute any product that's derived from it. So how can we actually address issues stemming from bringing our CAD data to a GIS environment? By adding a topological dimension to our drawings, we don't just get an enhanced visualization of our data, but we can also validate the relationships between multiple layers of otherwise fragmented pieces of information that appear to be unrelated and collect evolved data analytics from it. In CAD schematic representations, the descriptive data is typically bound to its drawing components as individual layers, but if we flip that over to the GIS environment or a GIS counterpart, we'll actually be able to run data quality checks between these layers as interfeature checks. So bringing these geospatial types of analytics to the table is the advantage that we want and that a lot of facility managers are after. So what I'm about to demonstrate is how One Integrate Rules Engine can validate our GIS facility data and check for geometric errors as well as inconsistency in attribution. More importantly, we are going to fix the issues that we've actually found. So instead of what would typically be a manual process of QA or QC, we are going to run an automated workflow of rules to validate and correct our data. So let's take a look at how we can actually do that. So let's first view our data through our GIS Pro, which is just my choice of GIS application, but obviously we do have clients that utilize other kinds of GIS applications. So let's take a look at the campus data that we have here. I've got buildings, some building floors, building interior spaces, building floor plan lines, and interior space points. What I want to show you here also is that this is multi-dimensional, or it's three-dimensional. So you can definitely toggle between the different floors that we have on this data. So if I select some at a certain location, based on the locations of these geometries and how they spatially interact, they have corresponding information in here, such as space point identifiers, building numbers or building IDs. We are also going to be checking information on their elevation and floor area, just to name a few. So let's go ahead and test these expectations that we have for how our different features relate to one another. So this is the One Integrate Rules Engine that we're seeing here. We have a list of tasks that make up a workflow within One Integrate, which we refer to as a session. So a session always has to start with opening or loading in our data from a data store. A data store is any source of external data that's being brought into One Integrate. So we're going to talk about more of that in a little bit. So once I've loaded in a sample of our campus data, I'm going to go ahead and hit play so we can push these objects through the rules that we're asking for them to conform. So let's look at what some of these rules are. The essential geometry checks, these are the out-of-the-box set of rules that we have for OneIntegrate, and they are meant to identify common geometric issues such as duplicate features, kickbacks, spikes, and self-intersections, just to name a few. What I do also want to point out here is these checks in particular have been written as generic rules, meaning a single rule runs on every single object that's been loaded. So for example, I didn't have to write multiple versions of this check for duplicate features check because it is checking for duplicates on everything, regardless of feature class name and regardless of dimension. The next set of rules that we have here, all right, we're looking at building floors and building interior spaces. These are the rules that have been written specifically for our campus data. These are the customized rules that we configured based on the expectations that we have on the quality of our data. So let's take a look at some of these. For floor ID is not null, the question that we're asking here is, do all of our building floors have identifiers? For any of those building floors that have an identifier, do they actually match the building that they intersect? So notice that for this rule, we require an attribute and a spatial relationship to accurately exist between a building floor object and a building object. The next rule here, floor count match building table. This rule validates the floor count attribute of a building by counting how many building floor objects exist within it. Floor areas match is another example of an interfeature check. So here we want to validate three relationships between a building interior space point and a building interior space area. So number one is the point contained within the area. Number two is, do they have the same interior space identifier? And then number three is that floor area value they represent exactly the same value. I also have a rule here that looks for inappropriate overlapping between interior space areas on the same floor. And I also add another check here. This one looks for interior space points that might be plotted too closely together on the same floor. And what's nice about this is if we do find points that fail this rule, we can absolutely use OneIntegrate to build a buffer around these points and move them farther apart and fix it that way. So within seconds, we pushed approximately 3,000 features through these 20 validation checks. And what I want to point out here is the reason behind this high performance is that OneIntegrate operates on a spatially optimized object-oriented disk cache, which means that every feature that gets read into the cache is automatically indexed at the beginning. So it makes it easy for our rules to call in each feature, even as the rules increase in complexity. So one of the things that I also want to point out before we leave here is every time you finish running a rule, we actually get instant results. So what we're seeing here is for every rule that we're not seeing 100% conformance for, meaning we have non-conforming features for that rule. So for example here, our check for duplicate features check has a conformance rate of 99.53%. And that's because of the 2,824 objects that I ran this rule on, we found 13 that were non-conforming to the rule. So we have 13 occurrences of duplicates between these objects. So just as a preference, I have a separate floor plan line session. And what I'm doing here is I loaded in approximately 14,000 features. And the additional rules that I ran here are ones that we would routinely run for linear features in GIS, such as road networks and hydrography lines. So the sort of checks that we have here are checking for good connectivity between these lines, making sure that we don't have any overshoots or undershoots, making sure they don't overlap, and none of them contain other lines. So the next few rules here are a little more complex, and these are the door and wall gap checks that were originally written against CAD data for Google. And what it does is it ensures that doors are actually on the right layer and that all the rooms have an opening in the wall. So we're trying to make sure that if we find any features that should be a door are actually labeled doors, and we're checking that all of our spaces are accessible. So with OneIntegrate, we can share rules between projects and even between data sets. And that's through our tools here. We can download and upload and share multiple sets of rules and sessions. So what we were able to do here was reuse the same checks again for our GIS dataset, even when they were originally written for a CAD drawing. So for the two sessions that we just looked at, we were able to export out through a copy to task all of the features that failed at least one rule. So let's go ahead and take a look at some of these instances of non-conformance in our data. So let's bring in our issues, which dropped pinpoints or markups on our non-conforming objects, and it actually gives us which rule the feature failed in. So let's visit some of the bookmarks that I have that we can go through. So in here, it looks like we have building interior spaces that have been marked as having duplicate features. And from what you remember here, for the generic version of the rule of the duplicates check, it simply said that two or more objects in the same class can have the same geometry. But obviously, we want to take into account that we actually have different floor levels in our data. So I wrote an enhanced version of that rule called the check for duplicate rooms. And what this check is saying is now two or more spaces on the same floor can have the same geometry. So among the interior spaces that I've selected here at this markup, we are seeing that on the third floor, we actually have two spaces that they have the exact same identifier and they have the exact same geometry. So if I just flip through the others, we're seeing that they're on different floors. So these two right here look like they really are duplicates. Let's visit another one. Kickback. So this is another generic check that we run for geometries with kickbacks. So if I select one of these, our kickback is occurring on this first floor interior space. And what I really want to show here is that one integrator was able to drop a pin on the actual kickback, on the vertex that's causing this kickback to occur. That, as opposed to other validation software that can only provide information on the geometry with a kickback. And that really just leaves you to manually pan along the geometry edges to look for that kickback. So I really like that one integrator is able to drive you to the location of that kickback. So let's look at some non-conformances involving our attributes in our data. So our interior space point failed floor area is not null, and so consequently floor areas match rule. So all this rule is saying that the floor area attribute shouldn't be null. And on this point right here, our floor area in fact is null. But if we look at the corresponding building interior space with the same identifier, it actually does have a floor area value. It's 10.920846. So that's definitely a non-conformance in there. Let's look at one example where we actually do have values and not just a null versus a non-null. So for this specific one, our interior space has a floor area of 5. The point has a floor area of 5, but our space has it at 5.782739. So the way that we wrote this rule was that the value has to be exactly the same, but if we really wanted to allow a difference of less than a square foot for this value, we can absolutely reconfigure the rule to say just that. So we also have precision issues in our geometry. So we've got overlapping interior spaces in here, and one integrator was able to drop a point where this area that's being shared between them actually overlaps. So now let's take a look at some that we did for our floor plan lines. So our floor plan line connectivity rule simply checks that our lines are well connected. And this is how we were able to spot these two tiny interior walls that are essentially floating on their own. So if I zoom in here, we see that it's really just standing there on its own. So it might be that this was just drawn on a different floor, or it was inadvertently forgotten during edits. So in relation to that, we also checked that our lines don't have any overshoots and undershoots. And interestingly, what I saw here was all of these stair lines aren't snapped at their ends. How about we take a look at one of these floors? and zoom in here so we can actually see. It looks like really this stair line right here is overshooting where we would expect it to snap. So that's definitely non-conformance for that rule. So the non-conformance here is that we have edges that are being shared between these two different lines. And both of them, actually see these, it's these first two, both of them are interior walls. So it definitely would be a different story if they had conflicting line types. So I'm honestly not sure if it's valid to have it drawn this way, but for this rule, it would definitely be an issue to our overlapping rule. And we do have one that's similar as well to that. So in here, we have two floor plan lines. This guy right here on the first floor is completely containing another floor plan line sharing that same edge right there. So we flag those as non-conformances because they exist on the same floor. Right, so for the feature should be a door rule, let me actually narrow down our floor here. Here we go. So if I zoom out here a little bit, we're going to see that our arcs right here are all fuchsia because they're all represented as doors. But for some reason, this guy right here, let's take a look at what line type that is. It's been labeled as an interior wall. So we definitely identified an arc here with measurements that are consistent with all the other door arcs in the data, but it has failed the rule, again, because it has been tagged as an interior wall. Let's take a look at one last one. So this one is very similar as well. So before we take a look at this one, I want you to notice how its neighboring offices here, even though these doors are not arcs, we still have doors for these rooms. So right out the bat, you're seeing that this area right here already looks enclosed. And that's why, if I check this flag right here, it says it failed a rule that checks that the space has to be accessible. And just to make sure of that, if we zoom in, where we think those should exist, and they are not fuchsia, so all of the ones that we select in this location, they are all interior walls. So there is really no accessible point for this particular office space. So it might just well be that it was drawn on a different floor, or maybe it's a labeling issue as well. It was a different line type. So now that we have a good idea of what kinds of data quality issues that we're dealing with, how about we go ahead and try to fix some of these? So back in our workflow, we have actions here. So the actions listed here are rules that actually modify our data. So we want to clean some of the non-conformances in our data by removing those duplicate rooms that we found, smoothing out those kickbacks. We are also fixing our interior space points to match the interior space area's floor area value. And also want to show you here is for these next 5 rules, these are reruns of the rules that we just ran earlier. So what's nice about this is you can already check how the conformance rate has improved after the actions that fix our issues. So let's take a look at one of these spaces don't overlap rule. Our conformance rate is at 99.65. So let's take a look at how many non-conformances that is. So that's 7 out of the 2044 objects. So if we take a look at the spaces do not overlap rule run earlier, it was at 98.97, and we had 21 non-conformances. So we got it down to 7, but we didn't completely eradicate it. And what I wanted to show you here is these automated fixes, you really want to weigh the risk of overcorrecting. For build topology, for example, right here at the top here, this process is meant to align our overshoots and undershoots. It should also close up those gaps and overlaps in our data. But you should know that we're able to set a tolerance for the distances between the nodes, edges, and faces that we have in this data. And say, for example, if the overlap is more than 20 meters wide, don't automate and align those edges because it actually might be worth a manual review. You wouldn't want to create new issues when you're trying to fix them, right? So now that we have corrected our data, let's go ahead and revisit some of the bookmarks where we did have issues and see which ones we were able to fix. Okay, let's turn on and bring in our clean data set. And let's revisit some of these bookmarks here. So for the duplicates, let's see if we actually deleted the duplicate one on the third floor. And in fact, we did do that. For the kickback, we were able to smooth out and remove that vertex that was causing that kickback to actually occur. Let's see if we were able to update our interior space point. So initially, this one was null, and now it should match our 10.92846, which should now match the interior space. So if we rerun this rule, this interior space point would now pass and conform to the rule that we said it should. Let's take a look at the zoomed in version of our overshoot. And we should actually see this markup floating now. All right, there we go. So it used to extend all the way out here, and we were able to snap it in place. So if we do have precision issues that are completely inaccurate, or we have pieces of the data missing, OneIntegrate can also allows you to create new features out of whatever data you have. So we can write a rule that can create floor plan lines from the polygons of our interior spaces that don't have them. And that's in the case if we find an overwhelming number of nonconformances to some of the rules that we wrote. Now that we've seen a workflow within OneIntegrate, we can actually read in the data, we've run validation rules to find nonconformances, we've corrected those nonconformances in such a way that they do conform to the business rules now, and they have a resulting data set that meets our data quality standards. So what exactly does it take to build this workflow? So let's start from the beginning in our OneIntegrate session. And of course, our session has to start with bringing in our data. So let's look at our data store in here. And what I really want you to notice here is within this data store, I can select what type of data I want to read in. So on this list of data store types, we can see that OneIntegrate, in fact, is data agnostic. So OneIntegrate does not require you to have a spatial component to your data that you're bringing in. And this is how we're able to bring in AutoCAD or CAD drawings files or drawing exchange formats. We can also bring in flat CSVs. We can even connect to a database that's sitting in an SDE or a SQL server or Oracle or Postgres. And actually one of the most recent ones that we added in here, the data format that we support, is Google BigQuery. So if there's definitely something on this list that you'd like to suggest for OneIntegrate to support, we will absolutely do that for you. So once we have selected what type we want to use, we're able to verify the schema mapping in here. So it gives us access to the exact schema as a context to our rule writing, and we're seeing all the available attributes for each and every single class that we're bringing in. And what this is handy for, if we take a look at one of the rules that we created, let's take a look at floor areas match. So in this rule, we were able to provide our data store as a context while we're writing this rule out. So we know that we don't have to hard code anything. So let's actually take a look at what this rule does. It's running this rule on our building interior space point, and I simply selected that from the list of available classes that I can pick based on the context of my data store, and be able to look at which attribute on that table or in the schema I want to use on my rule writing. So in here, all this is saying is that for every interior space point object, there has to be at least one interior space area for which the space area contains the point. They have the same space identifier, and they have the same floor area values. So let's go back to what we just saw in the data source tab. We saw that OneIntegrate is data agnostic, that the rules engine can read in multiple data stores with a mix of spatial and non-spatial databases. So we also know that traditionally facility data is created using CAD software, and they're typically managed through database systems like Archibus and asset management systems like IBM's Tririga and Maximo. So we can take advantage of OneIntegrate's capacity to coordinate a standard set of business rules that we want all of our facility data to follow. So now that we validated in our clean or campus data, How about we cross-check that with other facility information that's being maintained by an asset management system? So the goal here is to be able to synchronize our CAD-derived GIS and the asset management system that's being utilized by a facility manager. So for example, the rule logic that you're seeing here on the slide, for example, we can validate that a room object in the asset management database has the correct square footage based on the actual calculated area of the room's GIS geometry. So let's take a look at how this workflow would be laid out. So in this session, we have connected to two data stores. So we are going to use our campus data, our FileG database that we just validated earlier. This is a GIS data set. And we are going to tap into our Oracle database, which stores the information for the asset management system. So it includes information about the people and the places. Specifically, there are two tables that we want to read in here, which is the employee information table as well as the room space information table. So let's actually take a look at what kind of information exists in our employee information table. So we're seeing here is for every single listed employee, they have location IDs for where their offices in the building should exist. So the expectation here is that these location IDs should match the space identifiers that we saw earlier for our interior space areas and interior space points. So let's run a rule to see how many of these records on the employee table match up with at least one interior space object. Okay, we just ran that rule, expecting that every employee has a corresponding interior space point. We have a 99.3% conformance. We found 3 employees that failed this rule. So for these 3 employees, we didn't find a matching location IDs, and we've gone ahead and cross-checked that. So what can we do to figure out why these location IDs went unmatched? So one of the things that I'm already seeing here is we can use the other attributes that we have in this employee table. Let's utilize the information that we have on the floor of the building, what wing of the building, the actual building ID, and the office identifier that's also on the record for this employee. So essentially what we're going to do next is track down where the space with this identifier is said to be in. All right, so let's take a look at one of these results here. So we narrowed down 1 for Steve, just to show you how we're cross-checking this information. We're seeing that the space office ID matches up, same building identifier, same wing. But what we're seeing here is that the space ID on the GIS side really doesn't match the location ID on the employee table. So we are clearly missing one character here, which is the second one, the capital A. So this should be an easy fix. So we're going to go ahead and change the location ID for Steve on this employee information table. And because we're going to fix that, the next time that we run that same rule, we should have 1 nonconformance less. So in here, we are left with 2 remaining nonconformances. And now we have, we still have 2 employees that we can find records for on the GIS side. That's just one of the ways that we can extract information from a table and verify that the same information actually reflects on the GIS side. We also had another Oracle table that we read in, so how about let's run a couple of validation checks for that as well. All right, so what information do we actually have on our room table? So we have space identifiers, and we also have the associated square footage or the area associated with these identifiers. So what we can do here is verify that value by actually calculating the space area's area and checking that that's consistent with what's listed on this table right here. So that's actually what the rule here checked, checking that the space area is correct. Let's see how many nonconformances we have here. We have 20 nonconformances for this rule. So actually, let's take a look at how this rule looks like. Now, because we're comparing information from 2 separate sources, we want to consider that maybe there's just a precision issue, which is why we have 20 nonconformances. So right now, the way that this rule is written is for every room space information record on that table, it has to have a building interior space that matches the ID, and they also have to match up the actual calculated area of that geometry. So let's say that we'll allow a difference of a square foot. How about we pad that number a bit and tolerate a difference of 1 square foot or a square foot? So let's take a look at the next rule here, because that's exactly how we reconfigure that. And this is the one that actually allows us to give an allowance of a foot in difference between the two values. So we got that knocked down to 50 nonconformances from the 20. So you can run however many of these validations and corrections you need to do to keep your asset management database synchronized with your GIS facility data. And then once you're satisfied, you can push a commit to that data and push the corrections back to your asset management database, which in this case was the Oracle table. So what we have just seen is how facility data and its mixed data formats can be integrated between spatial and non-spatial systems. We've seen how we configure business rules into validation rules within OneIntegrate. We have auto-corrected issues where we have data failing those rules. And to ensure that our facility data information is consistent, regardless of the data format, we were able to tap into those different sources simultaneously and pinpoint where and how exactly they contradict each other. So more importantly, again, we were able to automate the process of fixing what we identified as issues, which prevents the poor data quality contamination or whatever other processes would follow this. So the next webinar in the series is on CAD to GIS integration, where Kevin will do a deep dive into what it takes to migrate facility data from CAD to GIS and how OneIntegrate can automate a PAI or positional accuracy improvement process to achieve that high spatial confidence between geometries of different dimensions. If this webinar is of interest, please check it out. Thank you for tuning in and watching our webinar on facility GIS management and synchronization of asset management systems. Thank you again and have a great day.